Let's study alternating series. In the series we have a term -1 to power n plus 1 multiplied by some factors. And these factors, they are all positive, they are decreasing, and their limit as n goes to infinity is 0. If we have these facts, then the alternating series will converge. Here is an example. The example is the alternating harmonic series. And its terms are 1, minus 1/2, plus 1/3, minus 1/4, and so on. And we can draw this picture. In the picture we have the first partial sum, what is 1. To get the second partial sum, we need to go down with minus 1/2. So the second partial sum is 1/2. To get the third partial sum, we need to get up with 1/3. We see that we come a little bit up, but not so much that we would get to the same level as where we were in the beginning. Well, then to get the fourth partial sum, we would have to get down with 1/4. Again, we see that 1/4 is less than this 1/3, so we don't come so much down as we were before. So it seems that the sequence of partial sums will oscillate, and the oscillation will get smaller and smaller. So because of this phenomena, the series will have a limit, a sum. But how can we show our idea by calculating? The first partial sum is just the first term. The second partial sum is first term minus the second term. Because the second term is a little bit less than the first term, we must have that the second partial sum is positive. But because we have subtracted something from the first partial sum, we will get something which is less than the first partial sum. The third partial sum will be a1 minus a2 plus a3. We have added something after having the second partial sum, so we have something which is larger than the second partial sum. But the thing what we added here seems to be, let's see, we have that a3 is less than a2, so minus a2 plus a3 seems to be a negative number. So this number here is a negative number. So the third partial sum seems to be less than a1. That is less than the first partial sum. The fourth partial sum is like this. And now we have subtracted something from the third partial sum, so we obtain something less than the third partial sum. And let's see about these two numbers here. a4 is less than a3, so a3 minus a4 is some positive number. So it seems that the fourth partial sum is larger than the second partial sum. Now we have calculated enough, and we can see that we will obtain two sequences of partial sums. One of the sequences will be decreasing and the other sequence will be increasing. The sequence of the odd partial sums is decreasing and lower bounded, so this sequence converges. The sequence of the even partial sums is increasing and upper bounded, so also this sequence converges. So we have these two limits. The limits might even be different numbers, but we can see why they have to be the same number. The difference of s2n plus 1 and s2n is the term in the series a2n plus 1. Now, we know from our assumptions that the general term of the series goes to 0, so this difference will go to 0. Because of this fact, these sequences have to convert to the same number. So our limits are the same. The partial sums have a limit, and the limit is the sum of the series. So our alternating series will have a sum s, and the sum s will be in the middle of these inequalities. Now we can see that the distance from s to a partial sum is less than the difference between the odd partial sum and the even partial sum. So in this way we will obtain an error estimate. How far we are from the sum when we calculate the number Sn, the error is at most an plus 1 in absolute values. Let's see an example about this. Let's consider the alternating harmonic series and let's take its fourth partial sum. We can calculate the value of the partial sum and we will obtain that it's about 0.58. Now the last term, what we left out from here, it means an plus 1. It is equal to 0.2. So from our we have calculated this value. We know that the true sum of the series is between these two numbers, 0.58 plus 0.2 and 0.58 minus 0.2. The actual value of the series is 0.7. We can check the value by some computer software. So alternating series are actually quite easy to study.